The vision for Mars colonization is one of humanity's most ambitious goals. It's not just about exploring a new planet. It's about creating a new home for future generations. This journey begins with robotic missions that scout the Martian surface, searching for signs of water, identifying safe landing sites, and gathering crucial data on Mars' environment. These missions lay the groundwork for human exploration by providing insights into the planet's terrain, climate, and potential resources. NASA, SpaceX, and other space agencies are developing technologies to send humans to Mars. SpaceX's Starship is designed to transport large crews and cargo, while NASA's Artemis program focuses on testing key technologies on the Moon before venturing further to Mars. The goal is to establish a sustainable presence on Mars that can support human life for extended periods. Key to this vision is the development of habitats that can sustain life on Mars. These habitats will use in situ resource utilization, ISRU, to produce essential resources like oxygen, water, and building materials from the Martian environment. Advanced life support systems, renewable energy sources, and technologies like 3D printing will be crucial in making Mars habitat self-sufficient. But Mars colonization isn't just about survival. It's about thriving. This means building a new society on Mars with its own rules, governance, and culture. The challenges are immense, but so are the opportunities. From scientific discoveries to the expansion of human presence beyond Earth, Mars offers a frontier that could redefine our species' future. This vision will take decades to unfold, but each mission brings us closer to making it a reality. Surviving on Mars is one of the biggest challenges humanity will face in our quest to become a multiplanetary species. Mars is a harsh and unforgiving environment, with conditions that are vastly different from Earth's. The planet experiences extreme temperatures, with daytime highs barely reaching above freezing and nighttime lows plummeting to -80 degrees Celsius or lower. Additionally, the thin Martian atmosphere provides no protection from harmful cosmic and solar radiation, making it essential for habitats to be well shielded and equipped with advanced life support systems. Dust storms on Mars can last for weeks, covering the entire planet and significantly reducing sunlight. These storms pose a threat to solar-powered systems and can disrupt communication with Earth. To combat these challenges, missions must include reliable power sources like nuclear reactors that can operate independently of solar energy. The low gravity on Mars, about 1/3 of Earth's, will also affect human health over time, potentially leading to muscle atrophy and bone density loss. Astronauts will need to follow rigorous exercise routines and possibly use advanced medical treatments to counteract these effects. Water, a critical resource for survival, is not readily available on the Martian surface in liquid form. Instead, it exists as ice or bound within the soil. Extracting and purifying this water will be a key focus for sustaining life on Mars. Technologies such as advanced filtration systems and chemical processes will be crucial to make Martian water safe for human use. Communication delays between Mars and Earth can range from 4 to 24 minutes one way, which means that astronauts will need to be highly self-sufficient, capable of making real-time decisions without immediate support from mission control. All these factors highlight the importance of preparation, technology, and adaptability in ensuring the survival of humans on Mars. Mars is known for its massive dust storms, which are some of the most extreme weather events in our solar system. Unlike storms on Earth, Martian dust storms can cover the entire planet and last for weeks or even months. These storms are driven by the planet's thin atmosphere and its proximity to the sun, which heats the surface and causes wind speeds of up to 60 miles per hour. While that might not sound very fast compared to Earth storms, the low gravity on Mars allows dust particles to stay suspended in the air much longer, creating thick, planet-wide dust clouds. The dust in these storms is extremely fine, much like talcum powder, and it can infiltrate machinery, clog filters, and pose significant challenges to both robotic and human missions. Visibility can drop to near zero, making navigation and solar power generation difficult. These storms also pose risks to equipment, as the dust is electrostatically charged and can stick to surfaces, including solar panels, reducing their efficiency. In 2018, a global dust storm forced NASA's Opportunity rover into hibernation mode, and it never recovered. This highlights the challenges these storms pose to ongoing missions. Engineers are now working on ways to design Mars habitats and equipment that can withstand these storms, including dust-resistant materials, advanced filtration systems, and power sources that don't rely solely on sunlight. Understanding Martian dust storms is crucial for planning long-term human missions. Future explorers will need to be prepared for these intense conditions, with habitats that can withstand high dust loads and autonomous systems capable of maintaining operations during periods of low visibility. While Martian dust storms are a formidable challenge, they are also an important part of the planet's climate, and studying them provides valuable insights into Mars' weather patterns and environmental history. Revolutionary spacecraft and propulsion systems are the backbone of our journey to Mars. To transport humans safely across millions of kilometers of space, these technologies need to be highly advanced and reliable. SpaceX's Starship, a fully reusable spacecraft, is designed to carry large crews and cargo to Mars. With its powerful Raptor engines, Starship aims to reduce the cost of space travel and make interplanetary missions more feasible. It's built to be versatile, capable of landing on any planetary body, including Mars. NASA, on the other hand, is developing the Space Launch System, SLS, and the Orion spacecraft as part of its Artemis program. SLS is the most powerful rocket ever built, designed to carry astronauts beyond Earth's orbit and eventually to Mars. Orion will serve as the crew vehicle, equipped with life support systems and radiation shielding to protect astronauts during the journey. In addition to these rockets, propulsion technology is evolving rapidly. Nuclear thermal propulsion is being developed to offer higher efficiency than conventional chemical rockets, potentially reducing travel time to Mars. Electric propulsion systems, like ion thrusters, provide continuous, gentle acceleration, making them ideal for cargo missions that don't require rapid transit. To make these missions sustainable, we're also exploring the use of in-situ resource utilization, ISRU technologies. These systems will allow spacecraft to refuel using Martian resources, such as converting CO2 into methane for rocket fuel. This approach reduces the need to carry all the necessary fuel from Earth, making long-term missions more viable. The future of space travel to Mars relies on these innovative spacecraft and propulsion systems. As we continue to test and refine these technologies, we move closer to making human missions to Mars a reality, opening the door to a new era of exploration. Innovative habitat construction and life support systems are essential for sustaining human life on Mars. These habitats need to protect settlers from extreme temperatures, radiation, and the thin atmosphere. One promising approach is using in-situ resource utilization, ISRU, which involves building with materials found on Mars, such as Martian regolith. 3D printing technologies are being developed to create structures directly on the Martian surface, reducing the need to transport building materials from Earth. Advanced life support systems are crucial for providing breathable air, clean water, and sustainable food production. These systems will rely on closed-loop processes that recycle waste products into usable resources, such as turning carbon dioxide exhaled by astronauts into oxygen. Water recycling systems will purify wastewater, making every drop count in the resource-scarce environment of Mars. Energy generation is another critical component of Martian habitats. Solar power is a primary option, but it needs to be supplemented with other sources like nuclear reactors to ensure a reliable energy supply, especially during dust storms that can block sunlight for extended periods. Small modular reactors, SMRs, are being explored as a robust solution, capable of providing continuous power regardless of weather conditions. Inside the habitats, conditions will be controlled to mimic Earth-like environments, with stable temperatures, humidity control, and protection from radiation. Grow chambers and hydroponic systems will enable the cultivation of crops, providing fresh food, and helping to maintain air quality by absorbing CO2 and releasing oxygen. The development of these innovative habitats and life support systems is key to making a sustainable human presence on Mars possible. As technology advances, These habitats will evolve to become more autonomous, efficient, and capable of supporting larger communities, paving the way for long-term colonization of the Red Planet. Farming on Mars is a critical component of establishing a self-sustaining colony on the Red Planet. Given the extreme conditions, traditional farming methods won't work, so innovative approaches are being developed to grow food in Martian habitats. Hydroponics and aeroponics are at the forefront, allowing plants to grow without soil using nutrient-rich water solutions or mist. These systems are highly efficient, using less water and space, which are crucial in the resource-limited environment of Mars. Mars habitats will include grow chambers equipped with artificial lighting that mimics Earth's sunlight, providing the optimal spectrum for plant growth. LED lights can be adjusted to meet the needs of different crops, ensuring that fresh vegetables, herbs, and even some fruits can be cultivated year-round. Scientists are also exploring genetically modified crops that are more resilient to Mars' lower gravity, high radiation, and cold temperatures. Another innovative technique is aquaponics, which combines fish farming with hydroponics. In this system, fish waste provides nutrients for the plants, while the plants help filter and clean the water for the fish. This closed-loop system could be an efficient way to produce both protein and vegetables in Martian habitats. Growing food on Mars not only provides necessary nutrition, but also contributes to the psychological well-being of settlers. Caring for plants and having fresh produce available can help improve morale and create a sense of normalcy in the otherwise harsh Martian environment. As we prepare for Mars colonization, these innovative farming techniques will play a crucial role in creating a sustainable human presence, turning Mars from a barren landscape into a new home where life can flourish. Thriving on Mars will require careful attention to health, safety, and survival strategies. The lower gravity on Mars, which is about 1/3 of Earth's, can lead to muscle atrophy and bone density loss over time. To combat these effects, astronauts will need to follow strict exercise routines using specialized equipment designed to mimic the effects of Earth's gravity. Regular exercise will be essential to maintaining physical health during long-term stays on Mars. Radiation is another significant concern on Mars, as the planet lacks a magnetic field and thick atmosphere to shield against cosmic rays and solar radiation. Habitats on Mars will need to be equipped with protective materials, such as water walls or regolith-based shielding, to reduce radiation exposure. Spacesuits will also be designed with radiation protection in mind, ensuring astronauts are safe during surface explorations. Mental health is equally important, given the isolation, confinement, and distance from Earth. Long-duration missions can lead to psychological challenges, including anxiety, depression, and feelings of isolation. To support mental well-being, Mars habitats will include spaces for relaxation, exercise, and social interaction. Virtual reality and other technologies may also be used to provide a sense of connection with Earth and loved ones. Medical preparedness is crucial for Mars missions. Each habitat will need to be equipped with medical facilities capable of handling emergencies, surgeries, and routine healthcare. Telemedicine will play a key role, allowing astronauts to consult with specialists on Earth, while AI-driven diagnostic tools will help identify and manage health issues autonomously. Safety protocols will be a constant aspect of life on Mars, with astronauts trained to handle emergencies such as habitat breaches, equipment failures, and medical crises. With the right combination of technology, training, and support systems, humans can not only survive but thrive on Mars, paving the way for a new chapter in space exploration. Building a new society on Mars is more than just a technological challenge. It's a human one. As the first settlers arrive, they'll need to create a functioning community that balances individual needs with collective goals. Governance structures will be crucial, as Mars won't be under the jurisdiction of any one country. Instead, new laws and regulations will need to be developed to manage resources, ensure safety, and maintain order in a unique environment far from Earth. Social structures will also play a significant role in the success of Mars colonization. Future Martians will need to build a sense of community and shared purpose, creating traditions, celebrations, and even Martian holidays that reflect their new reality. This communal spirit will be vital for morale and cohesion, especially given the isolation and challenges of life on Mars. Communication with Earth will be delayed by up to 24 minutes, which means that Martian settlers will need to operate with a high degree of independence. This will require strong leadership, clear decision-making processes, and a culture of resilience and self-reliance. Education and training will be ongoing to prepare settlers for the varied and unexpected challenges of Martian life. Economic systems on Mars will initially be driven by the need to be self-sufficient. Over time, as the colony grows, there could be opportunities for trade with Earth, such as mining rare minerals or providing unique research opportunities. The development of local industries, from manufacturing to agriculture, will be essential for creating a sustainable economy on Mars. Ultimately, building a society on Mars will be an evolving experiment in human ingenuity, adaptability, and collaboration. It will test our ability to not only survive, but to thrive in a new world, shaping the future of human civilization beyond Earth. Mars missions have seen many triumphs and trials over the years, with numerous missions that have both succeeded and failed in our quest to explore the Red Planet. NASA's Viking missions in the 1970s were the first successful landings on Mars, sending back incredible images and data. More recently, rovers like Spirit, Opportunity, Curiosity, and Perseverance have expanded our understanding of Mars, discovering signs of past water, studying the planet's geology, and searching for signs of ancient life. However, not all missions have been successful. The Mars Climate Orbiter and the Mars Polar Lander, both launched in 1999, were lost due to technical failures. These setbacks highlighted the challenges of space exploration and led to improved designs and more robust mission planning. In addition to NASA, other countries and private companies have joined the race to explore Mars. The European Space Agency, India, China, and the United Arab Emirates have all launched successful Mars missions, contributing valuable data and showcasing the global interest in the Red Planet. Despite the challenges, the successes of these missions have laid a solid foundation for future human exploration. Each mission provides valuable lessons, refining our technology and strategies as we prepare for the ultimate goal, sending humans to Mars. As we continue to learn from both our triumphs and our failures, we're getting closer to making Mars exploration a reality. The question of why we haven't reached Mars yet, despite landing on the Moon over 50 years ago, is a complex one. While the Moon is only about 384,000 kilometers away, making it accessible within just a few days, Mars is an entirely different challenge. At its closest, Mars is about 225 million kilometers from Earth, with travel times ranging from 6 to 9 months. This vast distance introduces significant logistical challenges, including the need for advanced propulsion systems, reliable life support, and sustainable power sources for the journey. The Moon's lack of atmosphere simplifies landings and takeoffs, while Mars' thin atmosphere presents unique challenges. It's thick enough to affect landing, but too thin to provide significant aerodynamic braking, making Mars landings notoriously difficult. This thin atmosphere also offers little protection from radiation, requiring advanced shielding for both spacecraft and habitats. Another major factor is cost. While the Apollo program to the Moon was incredibly expensive, sending humans to Mars is expected to cost even more, with estimates reaching hundreds of billions of dollars. The technological and financial barriers are significant, requiring international collaboration and private sector involvement to make Mars missions feasible. Human health is also a key concern. The microgravity environment during the journey to Mars and the reduced gravity on Mars itself can lead to muscle atrophy and bone loss. Additionally, the long duration of the mission poses psychological challenges, such as isolation and confinement, which need to be addressed through careful mission planning and support systems. Despite these challenges, progress is being made. Space agencies and private companies are developing the necessary technologies and strategies to overcome these hurdles. While it will take time, the journey to Mars is not just a dream. It's an achievable goal, with the first human missions potentially launching within the next decade. Exploring the potential for life on Mars is one of the most intriguing aspects of our journey to the Red Planet. Scientists are particularly interested in the planet's ancient past, when Mars had liquid water on its surface and a thicker atmosphere, conditions that could have supported microbial life. Rovers like Curiosity and Perseverance have been exploring regions that once held water, such as ancient riverbeds and lake bottoms, searching for signs of past life. The discovery of organic molecules by Curiosity was a significant step, suggesting that Mars had the right ingredients for life. More recently, Perseverance has been collecting samples that will be returned to Earth, potentially holding answers to the question of whether life ever existed on Mars. These samples will undergo detailed analysis using advanced instruments not available on Mars, providing a more definitive search for biosignatures. Looking at the present, the focus is on Mars' subsurface, where liquid water could exist today, protected from the harsh surface conditions. Instruments capable of drilling into the Martian soil are being developed to search for current microbial life, which might survive underground where conditions are more stable. The search for life on Mars also helps us understand the potential for life elsewhere in the universe. If life ever existed on Mars, it would suggest that life can arise in diverse environments, increasing the likelihood of life beyond Earth. As missions continue to explore and bring back more data, we edge closer to answering one of humanity's most profound questions. Are we alone in the universe? Thank you for watching. We hope you enjoyed the video and found it inspiring. If you like what you saw, please remember to follow our channel to support us. Your engagement means a lot and helps us bring you more amazing content about space and beyond. Don't forget to like, share, and hit the notification bell so you won't miss any of our future videos. Thanks again for joining us, and see you next time.